Hello and welcome back. I'm Saurav Agarwal, and today we are going to talk about one of the most robust binary classification metric, that is ROC AUC score. So how would we measure the performance of our machine learning model? The answer is by using metrics. Metrics allow us to monitor and measure the performance of our model. You must have heard of some of the common classification metrics such as accuracy, F1 score, precision, recall, ROC AUC score, among various others. While some of the regression metrics are max error, R2 coefficient, and a lot others. I have provided a link to the list of metrics available in the scikit-learn package in the description below. Do check that out and let me know if you want to know any other metric in detail. So now continuing with our lecture, let us understand what are some of the prerequisites to ROC AUC score. Also, we will see what a confusion metric is along with precision and recall. In a binary classification setting, a confusion metric is a 2 cross 2 metric where on the one side we have the true class labels, on the other we have the predicted class labels. So the true class labels is represented as the first row represents the positive, the second row represents a negative, while on the predicted class the first column represents positive and the second column represents negative. So a true positive for a or a positive class which is actually true and predicted to be true is represented as a true positive instance, while a negative class which is actually negative and predicted to be negative is represented as a true negative instance. While on the other hand, a class which is actually positive but predicted to be negative is a false negative instance, and a class which is actually negative but predicted to be positive is a false positive instance. So now you understand the terminologies: true positive, true negative, false negative. Using these four terminologies, we will frame our other terminologies respecting to TPR, FPR, precision, specificity, or TNR. Okay, so TPR, true positive rate or recall, or sensitivity is nothing but how many instances are actually are predicted to be positive and are actually positive among all the total positive instances. So it is true positive by the first row, all the total positive instances that we have actually, TP by TP plus Fn. FPR is the number of false positives over all the instances which are actually negative. So it is false positive plus true negative is our denominator, upon which false positive is our numerator, which is our FPR. Talking of precision, so precision is something like how many instances that are actually predicted, that are predicted to be positive and are actually positive. So it is true positive over total predicted positives, the first column of our confusion matrix. Whereas TNR, total true negative rate, is our total negative instances over our true negatives. So Tn by the second row of our confusion matrix. Okay. Now you understand sensitivity, specificity, precision, recall. So one point to note here from an interview perspective. An interviewer often presents the question as what metric should you use in a particular setting, whether it should be a precision or recall, or what should you optimize for in a particular setting. For example, given a diagnosis of a cancer, you want to detect whether a person has cancer or not. A person having cancer is represented as a positive, whereas not having cancer is represented as negative under the diagnostic test. Now, in this circumstance, what should be your objective? Do you want to reduce precision, or do you want to improve your precision, or do you want to improve your recall? So precision in this instance would be a diagnostic text predicts that a person has cancer. Out of them, how many are actually having cancer, right? While a recall would be of all the patients that are actually having cancer, how many are predicted to have cancer. You understand the difference there? So in such kind of scenarios, how would you evaluate in this situation where you have to diagnose for a patient's life? In case a person had cancer and the diagnostic test misses out on the person having cancer, it would risk their life. So You should have a high recall in this situation of all the total positives, total actual positives. Your true positives must be high, your recall must be very high. However, even if a person does not have cancer and the diagnostic test says that the person has cancer, the person still has a chance of getting further diagnostics and understanding that the person did not actually have the cancer. So here, the true positive TPR is much more valued. So such kind of questions do arise in interviews. We'll cover that in a separate lecture altogether, but just I'm giving you an essence here. Also, there could be questions relating to what is the difference between sensitivity and specificity. Now, I'm sure you must be able to handle those questions. Okay, let me know in the comments if you want me to cover that as a very separate topic again. Okay, now continuing forward, let us understand the ROC curve. Okay, when we talk of ROC curve, you understand that it is a graphical representation or a graphical plot which is used to show the diagnostic ability of our binary classifier. Let us see from the image itself. If you see, this is our ROC curve, the the continuous curve, or the this curve which is denoted as actual test, this denotes our ROC curve. Practically, this would not be a smooth curve, it would rather be a zigzag based curve, or like with ridges and grooves. But for simplicity, we just make a freehand curve here. It is plotted against the TPR and FPR. Okay. Now, plot is generated by varying the cutoff threshold for positive class. We shall come to this point in another slide in some more detail. How do we plot ROC curve? But just understand that how this plot is generated. It is generated by finding out the TPR and FPR at different thresholds. Now, again, from an interview perspective, ROC does not depend on class distribution. That is why it is a robust binary classification metric. It is not dependent on how our positive and negative classes are distributed in terms of their constitution in the data set. Okay. Now this ROC is, you understand, this ROC is a curve. It is a graphical representation. If we have to compare two different two different classifiers, it would be useful to have a summarized measure for this ROC curve. One such summarized measure is the area under this curve, denoted as AUC score. To talk of AUC, it is equivalent to the probability that a randomly chosen positive instance is ranked higher than a randomly chosen negative instance. For example, there is a pool of positive instances and a pool of negative instances. You randomly select a positive instance and you randomly select a negative instance. What is the predicted outcome or the probability for this positive class versus this negative class? If the positive class is ranked higher than the negative class, we say that our classifier is doing a good job. Okay, a question for all the viewers here. Please pay close attention and write down your answers in the comments below. You can simply mark the options as A, B, or C. Given that a model, a classifier, binary classifier, and an AUC score, now what we are doing, we are scaling this model by a factor of 2. All the output that this model predicts, we just multiply it by 2. How would this change our AUC score, or how would this change our model's performance when measured in terms of AUC score? The question is clear to all of you. Now, what are the options? First, it would improve the AUC score because the prediction values are all farther apart now. Second option, it would degrade the AUC score since the prediction values are way different. Third, no change. AUC cares only about the relative prediction scores. We shall discuss this and the answer to this question at the end of this lecture. So stay tuned. Now, talking of interpreting ROC AUC score. So first of all, talk of interpreting ROC curve. ROC curve, the classifier that generates curves closer to the top left corner of the ROC, indicate a better performance. For instance, here, a curve that would be vertical along vertical starting at 0 0 and horizontal otherwise is the best ROC curve. Theoretically, this curve is the best ROC curve. Okay. Now a curve which is diagonal or which is at 45 degrees, here the TPR would be equal to FPR. This curve is the dump curve, or we can say the classifier which represents this curve is a dump classifier. It does not have any predictive capability. Why so? Understand this. If your TPR is equal to your FPR, then your model is randomly assigning any instance as a true positive or a false positive. It is like just picking up a point and assigning it a positive instance, marking it as positive. It does not care whether it is an actual positive or it is not a positive instance. So your chances of having a true positive and false positive are equal. Your TPR is equals to FPR, and your classifier is just a random classifier with no predictive capabilities. Now, from the curve, you can also understand that if your FPR is higher than TPR, it denotes that your false positive rate is higher and your classifier is not doing a very good job. While on the other hand, if your TPR is higher than FPR, then your classifier is doing a decent job. Okay. Also, the choice of threshold that we have for a final classifier would be to balance between true positives and false positives. So that is the criteria that is kept in mind. Interpreting our AUC scores. AUC score is scale invariant. It measures how well predictions are ranked rather than their absolute values. It does not care about the absolute values of the prediction. It only cares about the ranking of the positive instances compared to the negative instances. AUC equal to 1 is the best score. AUC ranges between 0 to 1 in both inclusive, and AUC equal to 1 indicates that the classifier is perfectly able to rank positive instances higher than negative instances, while an AUC of 0 denotes that a classifier is doing the reverse job. It is classifying the negative instances or ranking the negative instances higher than positive instances. Okay. AUC is classification threshold invariant. It measures the quality of the predictors. Since it is independent of the classification threshold, it is a summarized measure. It is a good measure for comparing our classifiers. Okay. Now, how do we plot the ROC curve? It is very important to understand the plotting of the curve. It is very simple. There is no scientific theory. Just it's very simple to understand. Just what we do, all the predictions that we have from the model, we arrange it in descending order. We select each output as our threshold or a cutoff, compute the TPR and FPR against that cutoff, and plot it on our TPR versus FPR plot. And we get an ROC curve. Very simple. Now, coming back to our question, since we know that AUC is scale invariant, so changing our model predictions with a scale of 2 would have no change in the AUC score. Hence, the right answer would be option C, no change. If you got it correct, congratulations. Now, thank you very much for watching the lecture. Hope you learned something new. If you haven't subscribed yet, do subscribe, hit the bell icon, and like the channel. See you in the next lecture. Bye bye. Have a nice day.